and my goal for this video is to teach you which one you should use when. All right. You could always use long division. You could always use synthetic division, but there's certain questions that lend themselves to each of these. Check it out. If we look at the worksheets that we've been working on this part of the homework, we're definitely going to use synthetic division. When do we use synthetic division? On any polynomial divided by a binomial that has a coefficient of 1 in the front. Okay? So what do I mean by that? If you have a polynomial divided by what number's in front? A 1, right? So if you have a polynomial divided by f plus 2 or x minus 5 or a minus 3 or a plus 4, right? Any single letter added or subtracted with any number, use synthetic division. Okay? So we're using synthetic division on any polynomial divided by a binomial that has a coefficient of 1. So all of these use synthetic division. X plus 4, x plus 3, on all those, it's hands down, no questions, nothing to think about. Synthetic is the best way. W plus 3, no problem. You have a choice whenever you have a number 2 out here in front of the W. Then things change. But whenever you have a W plus 3 or an X plus 7 or an M plus 1, on all of these, we want to use synthetic division. It's the fastest one. And we've already done some of these on previous videos. Do you guys want to see one right now? Just so you can see how easy it is? Yes, I want to see one. Okay, so check out number 16, for example. And once again, how do we do synthetic? The binomial that you're dividing by, set that equal to 0. M plus 1 equals 0. Solve it. Subtract 1. M equals negative 1. That negative 1 is what we're going to be plugging inside this like backwards capital L, a negative 1. And then right here we want a list of numbers, and that list has to be the coefficients, the numbers that are in front of each variable, representing every term from the highest power down to the smallest, down to the constant at the very end. So notice we have m to the power of 5. Do we have m to the power of 4? No. Do we have m to the power of 3? No. M to the power of 2? No. M to the power of 1? Yes. And the constant? Yes. So all those missing ones we have to represent with the value 0. Even if we were to do long division, you still want to represent those with 0. So starting with 3m to the 5th, the number in front of 3m to the 5th, the coefficient is 3. Now the number in front of m to the 4th, there is no m to the 4th, so you put 0. The number in front of m to the 3rd, not there, put 0. The number in front of m squared, it's not there, put 0. The number in front of m is a 1, and the number at the very end, the constant, is a minus 1. So this is the setup, and you start with the number 3, and you go 3, you combine it with whatever number is right here. There is no number right there, so 3 plus 0 is 3. As you go up, you multiply. Negative 1 times 3 is negative 3. As you go down, you combine. 0 minus 3 is minus 3. As you go up, multiply. Negative 1 times negative 3 is positive 3. As you go down, combine. 0 plus 3 is 3. As you go up, multiply. Negative 1 times 3 is negative 3. As you go down, combine. 0 minus 3 is minus 3. As you go up, multiply. Negative 1 times negative 3 is positive 3. As you go down, combine. 0 plus 3 is 4. As you go up, multiply. Negative 1 times 4 is negative 4. You put a line right here because whatever you get when you combine right here, that's going to be your remainder, which in this case is negative 5. So this right here is your answer. However, what you need to do is think this first term, 3m to the 5th, divided by m. That's going to give you the first part of your answer. Now, what is 3m to the 5th divided by m? 3m to the 4th, right? So if you look at this first number, it's already a 3. All you need to do is put an m to the 4th right next to it. Oh, man. So let me make some space here. So I have my 3, and all I need to do is put the m to the 4th right next to it. And then I have this guy, which is a minus 3. That's a minus 3. And then if you already started with the m to the 4th, you're going to drop down to m to the 3rd. And then the next one is a positive 3, so plus 3, and that's m to the second. And then we have a minus 3, m to the 1, and then we have a plus 4 at the very end, the constant. And then we have the remainder of negative 5. So you put minus fraction 5 over the original divisor, which was m plus 1. That is long. Now imagine doing that with long division. That would not be fun, right? So it's a lot faster with synthetic. So again, synthetic is way faster than long division. See, the higher your polynomial power is, the longer the problem is going to take, okay? So we know that on any one of these, where I have a w plus 3, a x minus 1, an a plus 4, we know we're going to use synthetic. There's nothing to think about. Use synthetic. Especially because, like right here on this w plus 3, what goes inside the box? The negative 3, right? It's really easy, right? Let's jump to something that's a little bit more interesting. On this other page, where it says divide with long division, I just wrote these notes right here right now. If you have a number in front of the binomial you're dividing by, then long division may be the best option. Or not, right? But let's check it out. Let's look at number 19. You see, if I had a really high power, then maybe synthetic would be the better option. But since this is not that high of a power, I want to show you how long division isn't that bad. Let me actually jump to this. I have the same problem written twice right here in my notebook. It's not my notebook, but anyway. So I'm going to do this one with long division right here. Inside the box is the 4x squared minus 2x plus 6. There were no missing values. I don't have to put 0x or anything like that. I do have all the powers represented from the highest power 2, 1, and then the constant. And it is divided by 2x minus 3. Notice there's a 2 right here. This is why I'm not doing synthetic, okay? So I have a 2x minus 3 out here. And then I simply think, instead of the whole thing divided by the whole thing, I'm going to think 4x squared, 2x, right? 2x times what will give me a 4x squared? 2x. Times 2x. And I'm going to put that 2x right above the other x term, okay? And it's kind of like distributing. We know 2x times 2x is 4x squared. Let's write that down right there. And then we distribute 2x times negative 3 is negative 6x. And we are subtracting. We put parentheses. We put a minus sign. That's like distributing the minus sign, putting a minus right there, and changing that to a plus. So when I combine 4 take away 4, that cancels out. 2 plus 6, that actually gives me a positive 4 with an x. Then we bring down the 6, and then we think 2x times what gives me a 4x? 2x times what gives me a 4x? 2. So you put a positive 2 right there. And then you distribute again. 2 times 2x is 4x. That's what we wanted, so it could cancel. 2 times negative 3 is negative 6. And don't forget the parentheses, because if you don't put the parentheses, you're going to think that the remainder is 0, but the remainder is not 0. The remainder is actually 12, because this minus sign changes that to a negative, changes that to a positive, which you end up with the remainder 12. So your answer, that's a positive 12. You have a plus 12 over the original divisor, 2x minus 3. There's your answer. Was it that bad? No, long division is not that bad, especially if your polynomial is not that big. Like if this were an x to the 5th plus x to the 4th minus x to the 3rd plus x to the 2nd, if it was a huge one, then maybe synthetic would be better. But let's show you how synthetic would work in this situation anyway. Same exact problem, and then we'll compare the amount of work. Okay, so to begin with synthetic, you got to have this reverse capital L, and you're going to put something in that box. What are we going to put in that box? Well, it comes from setting this guy equal to 0, and that's some work itself, right? Set it equal to 0, plus 3, you end up with a 2x, that cancels out, equals 3. Divide by 2, you end up with x equals 3 halves. Okay, so inside the box you have 3 halves. That already took some time. And a lot of students freak out with fractions. If you do freak out with fractions, you could jump to the long division that we just did. Now let's do the list of numbers representing every power from the highest power to down to the constant. There is nothing missing, so we're going to put a 4, a -2, and a 6. A 4, a -2, and a 6. Put the line down here. As you go down, you combine. 4 plus nothing is 4. As you go up, you multiply. 3/2 times 4. Now this is where it gets a little interesting. You could use a calculator and it'll give you the answer, or you could say the number 4 times the numerator 3. 3 times 4 is 12, but it's still got to be divided by 2. So 12 divided by 2 is 6. So up here goes a 6. And as you go down, you combine. -2 plus 6 is 4. As you go up, you multiply. 3/2 times 4. Once again, 4 times the numerator 3, that's 12. 12 divided by 2 is 6. So up here we have a 6 again. This is our remainder here. 6 combined with 6 is the remainder 12. Now, we get our answer from these digits, but let's think about this, guys. Think about this. What is the first term? Just like before, what's the first term? 4x squared divided by 2x. What should the first term of our answer actually be? 4x squared divided by 2x. 2x, right? Is that a 2? It's not. So I need to convert this to a 2 by dividing both of these numbers by 2 to make it a 2. If I would have said like 4 divided by 4, it would have been a 1. I would need to change this to a 1 by dividing everything by 4. Does that make sense? That's an important detail that we need to know. So when I say 4x squared divided by 2x, and if you're confused, you could write it out right here. You could say 4x squared divided by 2x. Well, that becomes 2, cancel the x, cancel, that becomes 2x. So I know I need a 2x as my first term, and this is not a 2. So I need to divide both of these by 2. So when I divide both 4's by 2, the 2 goes there, the 2 goes there. The remainder you don't mess with. The remainder stays the same, okay? But now you could write it as 2x to the 1, or just 2x. And then your constant is plus 2. And then your remainder is at 12. So that's a positive 12 over the original divisor, 2x minus 3. There's your answer. Let's take a step back, compare work. Same answer as before, right? 2x plus 2 plus 12 over 2x minus 3, 2x plus 2 plus 12 over 2x minus 3. Honestly, it's weird, but because this power was so small, the long division might even be faster, right? Even though it's long division. So it's up to you to decide whether you want to use long division or synthetic division. Again, when you have no number, when there's no number right here, like if it's just x minus 3, oh, then a 3 goes in the box, jump right into synthetic. You don't have to think about anything, jump right into synthetic. But because you have a 2 right here, when you set it equal to 0, you get a fraction, you got to deal with that fraction. I did. We dealt with it right now. It wasn't that bad. You could use a calculator also. But in addition to that, once you get to these answers, you got to double check. 4 divided by 2 is 2, not 4. So you need to change this to a 2 by dividing both of these by 2. Then you'll get your final correct answer. If you would have put x right here, then it would have been wrong. 4x plus 4 plus 12 over 2x minus 3, that would be incorrect. You got to think 4 divided by 2 is 2. That's not a 2. I need to make it a 2. Divide both of these guys by 2, getting the 2's, and then you put your x right there, and then you get your correct answer. All right, so maybe we should try another one. We just did 19. How about this? Let's do a longer one, I guess. That question right there, let's compare both ways, I guess. Or I don't know, should we compare both ways, or should we just stick to one? Which method do you guys think would be best? Synthetic? Okay, let's start with synthetic, and if we have enough time, maybe we could compare it to long division and see which one works out best. Anyway, what would be the value inside this backwards capital L, or this box, whatever you want to call it? 3 over 2, right? 3 over 2. Now, we did not show our work, but when you set this equal to 0, you add 3, that'll be a 3. Divide by 2, that'll be a 2. So 3 over 2 is your value that you're plugging in. How about the list of numbers right here? There you go. And let's put the line right here. As you go down, you combine. 2 plus nothing is 2. As you go up, you multiply. Okay, so think about this. The top number 3 times the number 2. 3 times 2 is 6, but it's over 2, so you still need to divide by 2. 6 divided by 2 is 3. So up here, we have a 3. Coming down, 5 plus 3 is 8. And going up, you're going to multiply. 3 halves times 8. Again, think of the number up on top. 3 times this number 8. 3 times 8 is 24, but you got to divide by 2, giving you 12. And then negative 2 plus 12, what do we get? 10. And then multiplying, 3 halves times 10. Again, 10 times the top number 3, that's 30. 30 divided by 2 is what? 15. So 15 goes up here. And this will be our remainder. And in this case, negative 15 and positive 15, the remainder is 0. Works out beautifully. So what is our answer here? Do I just put an x to the second right here? The question is, what is the first part of our answer? And how do we get the first part of our answer? By thinking 2r to the third divided by 2r. What is 2r to the third divided by 2r? It's 1r squared, right? And if you're kind of confused, you could write it. Let's write down 2r to the third divided by 2r. Well, the 2 divided by 2 cancels. You end up with a 1. And the r on the bottom cancels with one of these, leaving you 2 r's up on top. So the first part of our answer should be 1r squared. Now this is a 2. I don't want a 2r squared. I want a 1r squared. So what am I going to do with all these blue numbers? Divide them by 2. In this case, because this 2 needs to become a 1. That's what we did up here. It became a 1, right? 2r to the third divided by 2r is 1r squared. I needed this to be a 1r squared, not a 2r squared. So divide all those blue numbers by 2 to make it a 1. And the other ones become 4 and 5 because you divide them by 2 as well. And there is your answer, but you're just going to put the r to the second on that first one, the r on the second one, and the constant is 5. So we have 1r squared plus 4r plus 5. There's your answer. There was no remainder. So again, why do some students shy away from synthetic division when we have a number out here? Because you have fractions to deal with, right? That's the first thing. And then the second tricky thing is that when you get here, it's not exactly your answer. You got to think, what will my first term be? 2 divided by 2 is 1. That's not a 1. I need to divide it by 2, right? So there are 2 little details on synthetic division on these types of problems. Should we compare it with long division? All right, let's do long division. Inside the box is the first cubic polynomial. And on the outside of the division box is a 2r minus 3. And long division, you don't think of the whole thing. You just look at your first term and your first term, and you think, okay, 2r times what will give me a 2r to the third? That'll be an r squared, correct? So I put that r squared right on top of the other r squared, staying organized. It's like a distribution problem. R squared times 2r is 2r to the third. R squared times negative 3 is negative 3r squared. And of course we are subtracting. Let's put that subtraction in parentheses with the subtraction on the outside. Distribute the minus sign. That becomes a negative, which will cancel with that guy. Distribute it over here. That'll become positive. So you really have a positive 5 plus 3. That's a positive 8r squared. Bring down the minus 2r. And then again, you look at your first term, 2r times what will give us an 8r squared? What is it? 4r. And of course, we're going to put that positive 4r above the other r's, staying organized. And we're going to distribute 4r times 2r is the 8r squared that we wanted right there. And then 4r times negative 3 is negative 12r. And of course, we are subtracting. We need parentheses. We need a minus sign. Distribute that minus sign. That's going to become a negative 8r squared, which cancels with the above. And over here, that becomes a positive 12r. So negative 2 plus 12, that gives us a positive 10r. Bring down the minus 15. Last but not least, 2r times what will get us that 10r right here? 2r times 5. And that's a positive 5. Put that on top of the other number, the negative 15. Let's distribute 5 times negative 3. Right here, 5 times negative 3 is negative 15. 5 times 2r, that's 10r. And yes, we are subtracting. Sorry, I wrote it in blue instead of red. We're subtracting, and you distribute to both, which will cancel completely, which means your remainder is 0. And that's your answer up here. R squared plus 4r plus 5. Which one took longer? I don't know. I mean, I guess the long division took longer, but the benefits of this, of long division, is you didn't have to deal with fractions, and you didn't have to make any changes like we did over here when we had to divide the 8 and the 10 by 2, okay? So it really is totally up to you. I made this video to explain both methods side by side so you can make a comparison, make a decision for yourself which one you like to use. Like I said, the only no-brainer, the only thing for sure is if you don't have a number right here. If this is just the r minus 3, don't do long division. That's a waste of time. If it's just r minus 3, use a synthetic division. Get the box. If it's just r minus 3, you're going to put the positive 3 in the box. But if you have a number out here, it's up to you. Long division, synthetic division, whatever you feel more comfortable with. I hope this helps. This is what the quiz will have tomorrow. Tomorrow's Thursday. Friday quiz. Not Thursday. Friday.